Hello, cadets. Welcome to Leaders 411 Leadership Day 2020, the virtual version. We're here with Bob Bonelli, who is going to tell us a little bit about his background, and fascinating already talking to him. Bob, welcome, and thank you for being here.
I'm happy to be here.
Well, tell us a little bit, tell us about how you got to where you are, what you're doing now. It sounds very fascinating. I want to hear all about it.
Well, I'll try to take the brief version of it so we don't take up too much time with background, but I started my career over 40 years ago as an engineer, but took a 30-year diversion on Wall Street doing mergers and acquisitions and came back to engineering in 2011, had an idea for a different approach to natural gas vehicles. And basically the concept was to how do we lower the compression requirement so that fueling would become less expensive and therefore enable private fueling and allow a natural gas vehicle to be as prolific as an electric vehicle, and it's just as clean. Well, long story made short, we put together a company called Adsorbed Natural Gas Products, and as the name implies, our entire business and product was based on the concept of adsorption. Basically, in the presence of an adsorbent material, Boyle's law, which is a linear relationship between pressure and capacity, bends so that in the presence of an adsorbent, we can store more fuel at lower pressures than normally would be. So anyway, we proceeded with that, and over the years, we developed a unique business model. We kept our company very small, just a few employees, but we engaged two major corporate partners, and they brought all their engineering resources and scientific resources to bear. This product involved science in the form of the adsorbent material, engineering in the form of the storage system, and the automotive engineering that was necessary to calibrate our system to, in our case, the Ford F-150, and do it in such a manner that we maintained all the Ford vehicle warranties. So to do this, we worked with Worthington Industries, which is a New York Stock Exchange listed company, and Ingevity Corporation, which at the time we got involved was Mead Westvaco Specialty Chemicals. Spun off as Ingevity a few years ago, and they, of course, are headquartered here in Charleston. Ingevity made the material that goes inside the tanks. Ingevity, Worthington Corporation made the tanks. We inspired the development of the technology utilizing Worthington's engineers, Ingevity scientists. We patented the product, earned 2 US and 2 Canadian patents, produced production-ready vehicles, entered the marketplace, and just a few months ago sold the company to Ingevity Corporation. And now we are one, and I've stayed on to help manage the project.
I mean, that is a fascinating story. These cadets could hear, they could hear about M&A, you know, mergers and acquisitions for an entire lecture series. And here you're talking about a product that was an idea, an engineering idea, that you put together a company, you brought in the outside resources of a major company, their scientific and industrial production resources, and you got them to help you build this product. And I had to look it up. Adsorbent is different than absorbent.
Correct.
Adsorbent is, in my mind, it's like, okay, you've got a tank and you put natural gas in the tank, but it's got to be super high pressure, which makes it dangerous. But if you put something in the tank like a sponge or some material, some kind of thing, then suddenly, the pressure is much lower, which makes it safer, and you can store more and that sort of thing. And then you can put that whole thing into, like you said, into a Ford F-150 or another vehicle. So you got this big company to help you figure out how to do this. And then once you figure out how to do it, you sold it to the big company. I mean, hats off.
Pretty much. What it was the benefit to the larger companies was working with just a few people who can operate outside of the bureaucracy. And we raised capital, and in fact, Ingevity Corporation was one of our original investors as well. So what we did was we used our ability to move quickly and to go across various what would normally be corporate hurdles that may take a month, 2 months, 3 months just to get a project started. In that period of time, we would try 1 or 2 or 3 different things. And then by being able to work with Worthington Industries, we were able to use their manufacturing capabilities. So we didn't have big capital outlay. They actually put everything together for us. And then we went one step further. We worked with the appropriate regulators, and we developed we actually modified the existing manufacturing regulations that exist for storage systems on natural gas vehicles to accommodate our science. So we created a new standard that if someone wanted to compete with us, not only did they have to have the material, which was something that Ingevity made and had intellectual property rights to, but they'd also have to put it together in a integrated fashion, which we now had patent rights for. And then they had to be able to meet a standard that only we had the privilege of using for the next few years. So we did all that right. And then the big thing was we got together with Ford's calibration people, and we actually worked within Ford's system to calibrate our storage technology to the engine platform, most popular engine platform on the F-150, the 5-liter V8. And we earned the right to actually flash the Ford computer with our calibration to run the system. And all of that was proven in Ford's wind tunnels and environmental chambers. And the result was Ford said, okay, we'll maintain the vehicle warranty with your system on it. Ford has a program in place they've had for 20 years that they call a Quality Vehicle Modifier Program, QVM program. And if you meet certain standards with whatever you're putting on a Ford vehicle and you test it and you prove it and you don't disrupt the durability standards of Ford, they will allow your product on the vehicle and maintain all their warranties, especially when you're doing something like we're doing where we're changing the way the engine works.
Yeah.
So it all came together over the years. And again, it was just a matter of orchestrating all of these various outside resources that we had working with us. And now we're in a process of, as part of Ingevity, moving the product into the market. We've got about half a dozen small fleets around the country that are using the product right now, and we hope to see that expand.
Because it's a natural gas engine, does that mean that you have to, you're not going to a gas station to put natural gas in your truck? So you say fleets, are they operating like corporate fleets of F-150s at sort of certain bigger installations? Where are you seeding the use of these natural gas driven trucks?
In addition to what we did on board, we also worked with another company that had a private refueling appliance that was geared to high pressure refueling. Working when we actually take 75% of the compression out of the equation. We go from 3,600 PSI to 900, but we maintain 60% of the storage volume. So it's usable. And the result is that those refueling units become fairly inexpensive, and you use very little energy to compress the gas. So our technology on the vehicle is dual fuel. We maintain the gasoline part also, but for every amount of natural gas we use, we displace an equal amount of gasoline. And every gallon of gasoline we displace, we save roughly 5 pounds of carbon dioxide, or 25% reduction in greenhouse gas emissions, which, by the way, from a well to wheels basis is exactly the same as an electric vehicle saves. An electric vehicle is more efficient at the wheels of the vehicle, but you still have to generate the electricity, which is usually from natural gas. Then that electricity has to travel thousands of miles, and then you get heat loss. And then you have to charge the batteries. You get more heat loss. The laws of physics are a funny thing. Electricity may be 2.5 times as efficient at the wheels, but it's 2.5 times as inefficient getting to the wheels. So we provide the same environmental benefit, but it's much, much smaller cost, a lot less weight added to the vehicle. And we also preserve the full, all 115 years of the internal combustion engine. There's no range anxiety, because when we run out of natural gas, the vehicle automatically switches to gasoline. But we provide enough fuel on the vehicle with natural gas that if a business's operational day is 100 miles, which most businesses are 70 to 100 miles, our retail user's average commute's about 40 or 50 miles. And then they come back at the depot or their home and they refuel overnight. They're running on natural gas 92, 93% of the time.
Wow.
So we developed the entire solution. When we brought the vehicle to the market, we also brought the refueling appliance, And we also have ways for large fleets to develop customized fueling solutions that would be appropriate for them, but very much like an electric vehicle owner would lease a type 2, a level 2 electric vehicle charger to charge their electric vehicle. We have a similar type of offering with the refueling unit.
Wow, I mean, you use the word orchestration. I think that is a great word. You know, I am aware of how little I knew when I was a 22-year-old senior sitting in a classroom. But the process you have just described, what has happened from building an intellectual property moat through regulation change, through working with major industrial leaders to both provide the technology, to build the actual tanks, to work with a massive distributor, a Ford Motor Company, not just a distributor, but really a holistic end user of this product, and then to also lease the fueling capacity. I mean, this is an absolutely incredible story. It's going to make a great book, I think, Bob, and hopefully these cadets will read it. And not that you need to make any money selling books, I bet, but this is just a terrific example of, I mean, it's almost like a capstone project. You have to be savvy in engineering. You have to understand a lot of complexities in terms of how to orchestrate, arrange, and manage in an entrepreneurial fashion.
Oh, it's very true. You when you enter into something like this, number one, you have to solve a problem.
Yeah.
And people have been trying to bring this technology to the marketplace for 30 years, and it never got off the ground. They were missing some very important aspects of what the market was telling them. So the first thing I did was listen to the market. And once I listened to the market, I said, okay, I clearly understand the problem. And then the question was to find the right solution. And the key to the solution was to start with the right adsorbent material. And that's when, after a lot of research, we came upon Mead-Westvaco Specialty Chemical Division, which is now Ingevity Corporation. And most people don't know this, but every vehicle that's on the roads in the United States that's run on gasoline, whether it was made in the United States or was made elsewhere, since 2004, has a little Coca-Cola can size of canister of activated carbon that sits on top of their gas tank. That's called an evaporative emission system. And I'm old enough to remember refueling my vehicle and being attacked by hydrocarbons. That doesn't happen anymore. What happens is those complex gasoline vapors are captured in that little canister. And when you start your engine, they're released and they run the engine. That market is owned by Ingevity Corporation, and their carbon is saving the United States about 8 million gallons of gasoline every single day. It's remarkable. And this has been going on since 2004. So knowing this, we approached Ingevity, Mead-Westvaco at the time. We said, we think we have another application for your carbon. And that's how it all started. So the first step was understanding what the problem was. Second step was solving the problem. And then a lot of engineering after that to bring it all together and do it in a unique way, and then work with patent counsel to make sure we protected the intellectual property. And then we had to develop a supply chain and a manufacturing chain and everything we needed to do to get the product built. But that was only still part of the equation. Then we needed the platform to deliver it to the market, and that was the F-150. So we had to go through all of that. In the middle of all of that, we had to be mindful of regulation and safety regulations and manufacturing standards and so forth, which I said we work with the appropriate groups to modify all those and so on. And it was an intense effort over 8 years, staying focused, solving the problem, bringing together all the necessary chain of supply chain and manufacturing chain and the right approach to marketing and the right platform so that we can deliver the product to the market. That's what it took. In the meantime, in the middle of all of that, we had to raise capital. We had to provide a story for our investors. We had to keep our investors up to date. We had to do the mundane things necessary of running a company from day to, even though we were a very small group of only 4 people with these 2 major corporations, we produced quarterly statements and annual audited reports. And we ran this little company as though we were a major corporation,
Sure.
which made the acquisition very easy because we were totally and completely transparent. All you had to do was look at our books and you knew the entire story of the company.
So did it end up being the same adsorbent material in the current natural gas fuel tanks as is used on a typical gasoline vehicle?
The base material is exactly the same, but what we've done was working with Ingevity, we've encouraged them to make some modifications to it, not only in the chemical composition of the material, but in the form of the material. So, for example, our storage system is a cylinder, but inside that cylinder is a mass of solid activated carbon monoliths. Think of them as dinner plates. And the reason why it's not one big mass has to do with the way you would put the material together and get it to cure properly so that you have a consistency of the material density from one end of the cylinder to the other. And the best way to do that, the most economical way to do it, the easiest way to manufacture things was to do it in a series of monoliths. And then that sleeve of monoliths had to get into that cylinder, and that cylinder can't have any welds. So now you say, gee, how do you take an 8-inch cylinder that has a 1 1/4 inch opening and put these 7.5-inch monoliths inside? Well, the answer is the way the cylinder is made. The way a pressure cylinder is made, it goes through what's called a spin forming process where the raw cylinder is actually spun at 2,500 RPM, and through a process of heat and molding, a dome is formed on either end. So Worthington Industries does that. They're one of the largest cylinder manufacturers in the world. They would spin form one end close, load a sleeve of monoliths inside, spin the other side close. So one of our firsts was the first seamless spin form cylinder that was loaded with monoliths. So we had a number of firsts. We had to invent a number of things along the way, including processes to get this done. And this is where working with two corporate giants enabled us to do this. They were encouraged, obviously, to do it, not just through investment, but also because they wanted their product to sell. And we got a lot of engineering and scientific support necessary to do this.
I hope that the cadets that watch this appreciate the amount of expertise and knowledge and gumption really to get this done. I have a question for you. You know, for a young entrepreneur, sometimes they are hesitant to share their idea because they think, if I share my idea, somebody's going to gobble it up. But you have done almost the total opposite, which is, hey, I see your product, which is really good, but I see a different application for it, and I'm going to form a company that uses your product and your expertise and probably your regulatory relationships and your partner relationships with Ford and manufacturing. So you went directly into the belly of the beast and said, I have an idea. How could you do that and not be afraid that they would stomp you? And how would you advise other entrepreneurs that have an idea how to protect themselves as they approach an idea?
Sure. The answer is actually a little bit simpler than one might suggest. And that is to understand that a large company may have a product, but may have other things that they've got to do. Whereas if they tried to bring this to develop this to the point where it was production ready, it would take them months, if not longer, just to get started. And then how to allocate a budget. What are they going to not do rather than do? Whereas it's a lot easier to work with someone from the outside and say, well, we'll pull it all together. We'll go find someone to make it. We'll deal with the regulatory side. We just need you to help us develop this product, and we're going to guide you along the way. And then what we did was, as soon as we reached a point where we saw we were developing some unique intellectual property, that's when we called in patent counsel, and we started to pull things together and patent things. And what we would do is, in our patent process, we referenced the materials we were using and so on and so forth, but that's not what we were patenting. We were patenting the integration of the material, the way the cylinder works, the application into a unique piece of intellectual property. And that's what we protected. And we, again, working with someone like Ingevity Corporation, their goal is to sell more carbon. They make a lot of money selling their carbon. They'd rather have somebody else bring it into the market as an automotive product, and that's going to help them sell more carbon. When they decided to act on the acquisition, we reached a point where they said, you really need a lot of strength behind you at this point. So we could either make more of an investment in you, or why don't we just come together now? And we could always spin it off later on, but now we can bring together support, all of our staff, money. It's all the things that we could do as a big corporation now that we have a product. It's analogous to what the pharmaceutical companies do. Pharmaceutical companies will get behind a dozen, 2 dozen, 3 dozen small little biotech companies that are doing different things in targeted areas. And when they come up with something that works, the big pharmaceutical company will acquire them and bring them into their machine to actually go forward and produce that product and sell it into the marketplace. Similar type of arrangement that what we've done here. So yeah, if a young entrepreneur has an idea, the first thing I would tell them to do is document that idea very carefully and send it to themselves and their attorney. And then if it's an idea, more than just an idea, but something that is tangible, for as little as $1,500, they can file what's called a provisional patent, which is good for 3 years. And all that provisional patent is a line in the sand. It says, on this date, I thought of this. So if somebody else that they're talking to a week later, a month later, a year later, sees what they're doing and says, hey, we're just going to go forward and patent this. Well, they were too late, because that young entrepreneur spent the best $1,500 of his or her life and put a mark in the sand in terms of this is the date that we thought of it. And the U.S. Patent Office and international patent offices will adhere to that. That is evidence, proof positive of who had the idea first.
This is, honestly, we could probably make this a 6-hour interview, but I have to keep it under 30 minutes. And so being respectful of everyone's time here, I'll ask you one final question. Man, that's tough, but I'm going to ask you just one more, which is putting yourself back in the seat of a 22-year-old college graduate, which both of us have been. What one piece of advice would you give them? Man, I wish I had known this at age 22 that I know today through a career in mergers and acquisitions and an unbelievable career building natural gas tanks and accoutrement. What advice would you give those graduating cadets?
The best advice I could give them is no matter how strong you may feel about a concept, a product, an idea, listen to the marketplace that you think you want to bring it to. You need to solve a problem. That's the way you sell something. And the best thing to do is to listen to what the market is telling you. You see too many examples, whether they're young entrepreneurs or they're seasoned multinational corporations, who say, well, we're going to produce this and we're going to sell it into the marketplace. Sometimes that can work. Most of the time, to be successful, you need to spend enough time listening to what the market really wants. And that's the best piece of advice I can give anyone, whether they're 22 years old or they're 42 years old or they're 102 years old. Listen.
That is just terrific. Thank you so much for taking the time to chat with these cadets. I mean, the way you articulated so much of this information in such a short period of time, you got to take this show on the road. I don't know what the book is going to be called, but man, what a lot of great information you have to share. Thank you so much for the time. Very grateful, and that was a real pleasure. So thank you.
Well, thank you too. Good luck.